Welcome to this episode of the Structural Engineering Channel podcast, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, we speak with Matteo Jean Pietrobelli, licensed engineer in the US, Canada, and Europe, who is the principal and regional manager of Maffeis Engineering. We found Matteo through an article that was published on the new atlas entitled Russia's Massive Lakhta Center named Skyscraper of the Year. What an accomplishment. We will be speaking with Matteo about the design of the steel and ETFE Skylight in between the glazed facades of the buildings in Lakhta Center. Matteo will also expand on the design and loading process that was used and the type of fabric material, also known as ETFE. And we'll dive into that acronym later.
I'm your co-host, Matt Picardo. I'm a licensed engineer at DCI Engineers, practicing on structural projects in California. And I have an undergraduate degree from Cal Poly Pomona and a master's degree in structural engineering from UC San Diego.
And I'm your co-host, Alexis Clark. I work in Hilti's North American headquarters as the product manager of our chemical anchoring portfolio in the US and Canada. I'm a licensed professional engineer in Texas. I received my bachelor's in civil engineering from the University of Texas at Austin, and I'm currently an MBA candidate at Auburn. Before we get started here, I would just like to remind you that next week, February 21st to 27th, is National Engineers Week, or E-Week. It's a full 7 days of celebrating and promoting awareness of the profession of engineering. The National Society of Professional Engineers, or NSPE, offers a wide breadth of resources on how you can help spread the word and get involved during E-Week. You can visit NSPE's website at discovere.org. That's discovere.org for more information. We encourage you to get out there and support Engineers Week.
And now I'd like to introduce our guest for this episode, Matteo Pietrobelli. Matteo is a highly motivated structural engineer with a background in structural design, bridges, buildings, stadiums, and facades. The skill set he's developed and acquired along the years have allowed him to cover and solve various kinds of problems related to structural engineering. Matteo spent more than half of his life working and residing in different countries, including Switzerland, Africa, China, India, Europe, and the USA. He's cheerful, curious, humble, and proud to have already been exposed to the design and construction of worldwide renowned bridges and award-winning buildings. Now let's jump into our conversation of the week.
Matteo, welcome to the show.
Well, thank you so much.
So before you joined us, we briefly introduced you to our guests. And what I really want to know before we dive into today's really interesting topic is a little bit more about what you do on a daily basis at Maffeis Engineering.
All right. On one hand, as a structural engineer by education and by trade, I am involved on solving problems and in coordinating the project that we are currently developing in the New York office. On the other hand, as I'm also working as a principal and regional manager for the firm, and my role is also to deal with the finances, human resources, business development, and strategic assessments for the company on a nationwide scale.
Man, so you're not just the technical manpower, you've also got the business responsibility on your shoulders.
Yeah, because the thing is, the company was set it up in the United States a few years ago. So, during the startup phase, you kind of have to deal a little bit with everything. And then by the time we started to expand also with the team, I try to keep track of everything because I also tend to be very passionate about structural engineering. So I want to always have my hands on.
Well, good. You're the perfect fit for our podcast.
There you go. Fantastic.
Awesome. Welcome to the show, Matteo. Firstly, congrats on the work that you and Maffeis did in the Lakhta Center. I'm curious to know what type of material that was used in the design of the skylight. Can you tell us more about that? Because I've always, as a building engineer that works on, on buildings, we typically don't design those crazy looking facades and whatnot. So I'm curious to see that what went into that.
Of course, yes. Well, so the skylight on the Lakhta Center is an example application of ETFE films in a pneumatic structure. The ETFE stands for ethylene tetrafluoroethylene and is an isotropic thermoplastic polymeric material is manufactured in films. And what happened is that he also has an impressive tensile resistance. The average test results are normally between 6,000 and 6,300 psi. And the peculiarity of the ETFE is that also can be heat welded. Now, the peculiarity also of the application on the Lakhta Center is that the ETFE film can be pre-stressed through a pneumatic air, basically. So you inflate air inside and you pre-stress the ETFE into basically what is that specific shape of a pillow. And it also can be designed with single or multiple layer structures.
Very cool. Yeah, I know since we're on a podcast, it's kind of hard to picture it. But I know the one that always stood out to me was the Beijing Center in the 2008 Olympics, the aquatic center.
Yes.
It looked like the facade was like bubbles, basically, because it was the aquatic center. So yeah, this material is really cool. I've always wondered what it was because it seems you can all put it into all sorts of shapes and sizes, and it looks really organic. So yeah, really cool.
I have to ask, so I had to look up and Google search what this looked like for myself, because you were saying, that has this fantastic tensile strength and it's weldable. And I was like, well, what does it even look like? And of course, now that I see images of this, I've seen this before on projects. I work with chemical anchors, obviously. So I got to ask, is there a resin epoxy or something that hardens this material, or what's the hardening agent once you've kind of expanded this material with air?
Well, what happened is that the air will stay inside. There is an MEP system that works around it. So you inflate it with air, and then because it works with a pump and with the pressure gauge, the system, which is an electrical system, will be able to understand if the pressure is changing inside due to, for example, thermal expansions or due to the loads applied. So in relation to that, in relation to the specific characteristic of the material, it's able to basically gauge and to change the pressure inside, inflating or removing air from within. So wow. Basically, the ETFE is just a polymeric material, but okay. It's like having a sort of balloon that you inflate with air, and then you have to basically control the air inside.
That is fascinating. We rack up pretty hefty air conditioning bills down here in Texas because the summers are so hot. And now I'm just thinking, what does a building like this even look like? I wouldn't want to get that bill.
There's a whole MEP layout that goes in with them. This is why the design normally it's very well entangled between structures and MEP, at least for this specific type of application.
Yeah, absolutely. That's got to be an interesting collaboration with different trades with this specific building material. I'd never thought about it from that perspective. Perfect. So you already introduced us to the main material that we're going to be asking some specific questions about. But for our listeners that aren't terribly familiar with fabric materials like myself, can you explain the main categories that fabric materials consist of and what each of them is and where you might see it?
Yeah. Well, okay. Well, so before to start, there are two main categories: fabrics and films. Fabric is defined as an anisotropic material. It consists of normally interwoven threads or yarns on a loom, and they normally go in two directions, and those directions are normally perpendicular to each other. This type of definition applies to natural as well as synthetic fibers. So the type of fabric that you normally have for sweaters or for shirts, that type of definition applies very well also for synthetic fibers. In fact, the commonly used yarn materials in textile architecture are normally polyester and fiberglass. Now, if you have polyester yarns, they are the base to obtain PVC membranes, while fiberglass yarns are the base to obtain PTFE fiberglass membranes. Then we have films. On the other hand, they are isotropic thermoplastic materials, and they are obtained by forming a single material. The two common type of application for films are the PVC films, normally used for indoor spaces or indoor applications. And then you have ETFE films that are instead used for outdoor applications.
Awesome. Could you go into I guess like going into an example, why did you decide to use the ETFE material in the Lakhta Center? And yeah, I'm curious to know like why is it good for, I think, indoors or outdoors or certain applications?
All right. So I mean, so the ETFE choice in this case was due to the coordination with the architect and with the owner. The reason why we ended up using the ETFE because what happened is that the ETFE, or in general any other tensile material, is mainly used to obtain lightness for all the structural application, and also to obtain purpose in from an architectural language point of view. Um, the ETFE can be considered also a good alternative for glass because um, it can perform very well also in terms of thermal insulation. If transparency is necessary, the ETFE can be print with the high level of transparency. If you want to use it with a certain level of shade, you can also print with patterns or with different transparency. It's really, really easily customizable. The good thing is also that it is 100 times lighter than glass. So
Oh,
what
wow.
happened is that due to these lightweight characteristics, it can be used to cover long span structures, and there is a less, or at least the supporting structural components for the ETFE, they tend to be lighter because of the lightweight characteristic of the ETFE as well.
That's really interesting. The fact that you mentioned, it can be transparent, it can have patterns. I can see this as like an architect's dream in a lot of ways because it has this kind of futuristic look to it, and it could be used very interestingly to draw your eye to different parts of a building, or to accentuate something. So I think I'm surprised I don't see this more often, but I think in a regular metropolis, it's got limited uses thus far. So I'm curious, do you see more like a larger market for this moving forward? Are there more projects that we should expect to be seeing this on?
So there are more application that has been ventured by architects so far, and by owners as well, as they're really seeing a benefit into this type of application. What happened is that we always have to be very careful on the way we use applications, and to don't speculate too much on their use, right? So what happened is in Europe so far, we can say that between Europe and Asia, probably 80% of applications of ETFE have been developed over there. The 20% though has been actually increasingly is increasingly going into the American, the Canadian market. In New York so far we have the Culture Shed, for example, and that's an application of ETFE pillows. But there are different type of application that right now are going into it, and there would be where the ETFE would be used also in the United States in the future.
Very interesting. Okay. I'm going to keep an eye out. I hope I see more of these around. Maybe they'll have one in Fort Worth sometime soon. Um, Perfect. From a structural and from a
Oh,
technical point of view, I am curious, can you share with us a little bit more about the design and loading process that you use during a project like the Lakhta Center?
yeah. So I mean, the structural analysis of the ETFE structure for the Lakhta Center, it was done in relation to the Russian design codes, of course. Um, because the ETFE pillows work as a pneumatic structure, um, so apart from the specific provisions of dead loads and the construction loads, especially these last ones, are very important to consider for tensile membranes. So besides all these provisions, we also have to consider the short and the long-term behavior. So in relation to the short-term behavior, we analyze the foil considering the action of the wind as per the results of the wind tunnel test. While for the long-term behavior, we analyze the effect of the snow. Being in Russia, I would say snow is pretty common. So that was a very important part of the design.
I'm curious for this. I know this is a special shade structure. So is everything done through testing? I know, when we're doing a typical shade structure or canopy, it's per code, ASCE. in the US or the building codes. But for these, is everything like custom made, and then you have to do the wind tunnel testing, and so it's not really code based in terms of typical design?
So there are certain design guidelines in relation to that. There is the European standards for membrane structures. The ASCE actually developed guidelines, which if I remember correctly, is called the ASCE 5510. I'm gonna, please don't quote me on that. I'm gonna have to be, I will have to check. I don't remember exactly the number, but that's a guideline for tensile structure, and that considers fabric and films. So that's a good guideline. But then what happened is that in relation to the design, everything goes into the engineering approach, and that requires some level of expertise.
And so all of these are categorized as tensile structures, whether you're using the ETFE or the fabric then, right?
That's correct. So if you, for example, ETFE can be used for a pillow. So when you have 2, 3, or 4 layers within each other and you inflate it with air, it becomes a pneumatic structure. And you can use the ETFE as a single layer. It's a more rare type of application. But when you have a single layer, the ETFE doesn't basically perform very well unless, of course, you consider some cables inside that basically will be the structural components of the ETFE.
Gotcha. And my last question, is there like a specific, is the fabric and the ETFE, are they different? One seems like plastic and one's fabric. I feel like the plastic would be a lot more sturdier, but then the fabric is pretty fabric. Is there a different design approach or design method for each of those?
So I mean, for the ETFE components, what happened is that, so from a technical point of view, the ETFE needs to be considered as a cladding material.
Gotcha.
So it basically requires specific details, connections, waterproofing, and so on. But from a structural point of view, what happened is it is important to basically to note, what is to define that not only ETFE, but in general, all tensile structure work because of tension. That means that the tension is transferred to the main supporting structure as horizontal forces. You know, this is something that is completely different from other standard and more traditional structures where you may have a floor and the vertical loads are transferred to the main supporting structure as most of the time as vertical reactions. So, you know, the ETFE can be used as a single layer membrane, as I said, or sometimes as a double, triple, or quadruple layer in a pneumatic structure application. In general, if it's not ETFE, but is a tensile structure overall, like as we mentioned before, a PVC or a PTFE, there is a process, it's called form finding process, that basically will allow to obtain the best shape in relation to the forces applied to it. And there are different methods to do it. After you basically define the shape, then there are, of course, all the structural analysis with the load combination, the load applied, and as a result, you basically ended up understanding the required thickness of the material. And if you have cables, depending on the type of application that you have, also the required dimension of the cables. That makes sense?
Yeah, I think that's where even all the, custom programs or the parametric studies that I've seen some engineers and BIM designers talk about. I think that's really cool, where kind of the optimization of your model.
Yes, that's correct. And also, I mean, if you have pillows, the other thing you have to consider, as I mentioned before, there's a whole MEP system. So you have piping, blowers, back panels, and, you know, because at the end of the day, you want the pillows to remain inflated.
I have to just share really quickly. I had the most terrifying vision. I know we usually give architects a lot of trouble because they sketch something pretty out on a napkin and say, hey, make this stand. But I was envisioning this, like, you know, you could do so much with the structural pieces that kind of form each of these pillows. And I was thinking, man, you could make something really intricate, and it could be, you know, you could make designs in this thing, and you could do all these different abstract shapes. And I was thinking, man, Matteo's going to hate me if I was if I was the person on the other side saying, make this beautiful, complex thing where none of the shapes are the same size and they're all a little bit different. And then the fabricator would be upset. I could see this very quickly becoming a complex and beautiful end result, but something very difficult for you in the meantime.
Yeah, it's my day-to-day life. Actually, it's related to accomplishing those type of dreams, and that makes us happy. When I say us, it's really a cultural approach, and that we have in the firm. We know that when we start to talk about this type of structure, creativity becomes automatically, it sparks everywhere. And so you ended up having double curvature shapes. You ended up having structure that tend to be very complicated, and so requires a very specific type of analysis and a certain level of expertise. But we're very, very keen into actually doing this type of structure because it makes us happy. We're solving problems, and as structural engineers, I think that's the best you can ask for.
Man, that's really a fantastic way to look at it. I love your passion for solving a very intricate problem, and something that's very unique to, I think, structural engineering. I guess I kind of want to open this up to hearing more about your experiences. So can you tell us about some of the different case studies and different projects that you've worked on in the past that use similar or different alternative materials? And when I mean alternative, I mean it's just not concrete, steel, or brick like we're pretty used to using here in North America.
Yeah, so the firm starts with the specialization in long span structures and stadiums. So the way I envision, to answer your question, I'm gonna go first with the ETFE applications, or in general for tensile structure application, and an example is the new Verona Exposition Hub entrance in Italy. It's a beautiful canopy made of ETFE pillows. Another type of application, more from a facade perspective or double skin application, is the American Embassy in London. Speaking of what Matthew before mentioned for the Aquatic Center in Beijing, we did something a little bit similar in Germany, in Chemnitz. It is the Chemnitz station. The other one that I think you will like a lot is the Centre Pompidou of Metz in France. It's a beautiful double curvature canopy with the supporting structure made of wood. So we work on the PTFE application, and then I would also say, mentioning again as a double skin application, the King Fahd National Library in Riyadh in Saudi Arabia. That's a PTFE application. But that's in relation to, again, a tensile structure. But then we work in different type of application, not only in tensile material, but also in steel, concrete, and timber. And one of our jewel, I would say, is the Al Janoub Stadium for the World Cup in 2000. I think it's 2022. It's coming up.
Oh my goodness. That was quite an impressive list. I am definitely going to make sure that we have some kind of links for our audience to come by and be able to check in the show notes and see all of these fantastic structures, because I'm kind of just Googling some as we go along, and they're mind blowing. They really are elegant and very eye-catching structures. These are just amazing.
Yeah, just again, looking at those, it's cool to talk to you about it, because you always see those structures, and if you're used to doing typical building designs, like how are they taking all the loads? What is that thing made out of, and how is it standing up? So it's really cool.
It's a lot of hours spent into that, but again, it's a passion, right? So it's something that we do with of course, a lot of professionalism, but at the same time, it makes us happy.
That's fantastic. So just to kind of wrap this up and put a nice big bow on this, Matteo, you have such an impressive resume. You've been all over the world. You have worked with all these bizarre materials, and the results that you create are obviously fantastic. If you could give some kind of wisdom to our audience about career or personal development or growth, what was it that you want to share?
Well, I'm myself still young, so I will probably share what I've been doing so far and what it's basically keeps driving me, and that's exploring. I really never stop exploring. So if there is something new that I want to learn, I just do it and I learn it. If there is something that makes me curious, I always try to look and learn more about it. And I think looking at myself fresh out of college, I did not know anything. I mean, at least I didn't know what would I be able to do or what would be actually my real passion besides what I have been studying in college. And what really helped me is this constant, I would say, need of learning new things and keeping myself curious. And so I think that's what keeps me going and moving forward in my career and in my structural engineering applications.
I love that. I think that's such a beautiful sentiment. I think a lot of us, when we graduate college, we either have this idea of, oh, I've managed to obtain this really fantastic and challenging degree, but there's always more to learn. And hopefully that hunger for learning is instilled in college. And we learn a lot to get a license and to be able to go through continuing development. And we're always continuously
absolutely.
learning of the infrastructure of our industry. But I think the other thing is just, yes, having that natural curiosity. And I've recently started setting aside 30 minutes each day and I just read. I read whatever I want, but I have to read. And whether it's articles, it may not have to do anything with industry. It could be about, politics, or I'm reading about gardening right now. You've got to have something that keeps your mind moving and that keeps your mind expanding. So I think that's a really beautiful sentiment. Thank you.
I totally agree. No, thank you too. And, it's just to conclude, I think our industry as a civil engineers, but then specialized in structural engineering, it's a always growing field, right? Where applications are becoming limitless. So as you said, you always have to nurture yourself, not only with the topics or papers specific to the topic, but also with expanding your knowledge and your curiosity that into subject that goes a little bit outside of our field of application. Because you never know what you're going to find, right?
Exactly.
Couldn't agree more. Matteo, thank you so much for joining us on the podcast today.
No, thank you so much for having me. I really appreciate it.
We hope you enjoyed the episode today, and we'd love to hear your feedback, comments, and/or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, which is episode number 45, as well as links to any of the resources, websites, or books mentioned during this episode. Don't forget to subscribe on Apple Podcasts or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.